Welcome to Living Mirrors with Dr. James Cooke. My guest this week is Inês Hipólito. Inês is a philosopher and assistant professor at Macquarie University in Sydney, Australia, specialising in cognitive science, philosophy of mind, and artificial intelligence. She's the founder and CEO of Mission AI and lead ethicist at Versus AI. Today, we discuss cognition, complexity, and artificial intelligence. Hope you enjoy the conversation. Okay, I'm here with Inês Hipólito. Inês, thanks for being on the podcast.
Thank you so much. It's my pleasure, James.
Yeah, I'm very excited to speak with you today. I actually don't think I've ever read so many papers for an individual guest. You have a very kind of broad range of very interesting things you've written about. So yeah, thank you for your research. I really enjoyed it. And so maybe to begin with, we could talk about the kind of big picture of where you're coming from, because there's this kind of traditional approach to cognitive science, to studying the mind, that relies a lot on kind of computation and kind of machine analogies and representations, which we can unpack with that terminology. But you're coming from this 4E cognitive science perspective, right? So maybe you could explain a bit about that.
Yeah, absolutely. So the 4E is an approach that has been around for a while, but it's not quite mainstream in cognitive psychology or in analytic philosophy of mind. So 4E cognition, it's quite hard to provide a comprehension or a description of 4E cognition that they'll be doing justice to it, but I will try to say a few thoughts about that. Because the reason being that it is not one single approach for e-cognition. Some would say e-cognition because there may be more than 4 E's. So it is varied and it is quite interdisciplinary, and it is going to have roots in many different other approaches or traditions, including Eastern philosophy of mind. So for that reason, it is quite an unfair task to try to summarize it and do justice to it. But let's maybe walk through some of the most prominent E's and say a few words about them, and potentially look at how a common features between the E's place e-cognition in a counterposition or against a more popular perspective or approach in philosophy of mind and cognitive psychology, which is the theories for the people that are listening to us, the theories that fall under another category, which is computational theory of mind. And that itself is already a field that is incredibly rich and also has many traditions and approaches. So e-cognition sits in the counterposition to that because it rejects premises that come up uniting or unifying different computational theories of mind. So the different E's, maybe let's start there. What they do is they question many things, but we have to start somewhere. They question and reject the notion or the claim that mental representations are the mark of the mental. Or, I'm going to put it slightly differently, that mindedness or mind or minded life reduces to mental representation. In what sense? Well, in the sense of we can explain and understand all that there is to living experience if we can lay it out as or in forms of mental representations. So this is very traditional mental representation, computational theory of mind as well, in traditional analytical philosophy of mind. So that's let's say that's the quite common ground that is going to unify or unite different E's. But it's going to do that in a range. So what that means is that you can think about the E's as being distributed within a range of how much do they question mental representation as being a fundamental part of the explanation or the description or the understanding of mental life. So I'm going to start with the one that is closest to mental representation as being a fundamental part, and potentially even closest to a more computational theory of mind tradition, which is embeddedness, right? So very few researchers today, or cognitive scientists or philosophers of mind today, would reject the view that the body plays a role, or the body is situated or embedded. That's the embeddedness, that the body is embedded, or the brain is embedded in a body, to be more precise, and then the body is embedded in an environment. Not many researchers or cognitive scientists will reject that. That's embeddedness, right? So then what is going to come up really interestingly is that the other E's are going to come up to precisely explain in what sense is this embeddedness, or does this embeddedness take shape and form? Like, in what sense is the brain embedded in a body, and is the body embedded in an environment? So I'm still sticking with the embeddedness description in literature or approach. So very few people would challenge the embeddedness perspective. So then as we make our way towards and away from computational theory of mind or mental representation as the main focus of explanations and understandings of mental life, then we have embodiment, right? And embodiment has these roots in phenomenology. So it is a well-established field. It's not news, and it goes back to the works of Husserl, Merleau-Ponty, Simone de Beauvoir, all of these existentialists. That's where we find this very rich literature. And here the view is that the body serves a fundamental role in the experiential life, in the mental living that one has. So that's the embodiment perspective, placing this focus in the embodiment as a condition for us to understand mental life. So if we're going to have an explanation or understanding of mental life, then the body must come into place to explain, or to be part of a fundamental part of that explanation. We are not going to be happy with mental representation alone, or mental life explained in terms of our beliefs are formed. So then, as we move further away from that, we find other accounts, such as the extended mind, right? The extended mind is actually, I should have said extended mind before embodiment, because the extended mind is closer to computational theory of mind, it being a theory that comes within functionalism, within connectionism, and within predictive processing theories. So the extended mind will have it that the body plays a functional role in understanding mental life, such that brain and body are going to be same kind of prediction computational information processing system, right? So that's the extended mind, and that's why it's placed closer to computational theory of mind, because the understanding of the body is that the body works or functions in ways that it is a prediction processing of information. And this is completely different to what embodiment would have it as the body, like in researchers that follow the workings of Merleau-Ponty or Husserl, or any phenomenological understanding of the body, is what it's called strong embodiment, in comparison to weak embodiment, where the thought there is that the body serves the role of being part of that information processing system, right? So that's closer to computational theory of mind. So then after embodiment, we have enactivism, for example. And enactivism is slightly different. And I want to emphasize that there are many points that are common between embodiment and the enactivists. It's just the angles are slightly different, where some aspects are emphasized as being more kind of a lenses than the others. So it's just two slightly different angles, but they do share common grounds. Enactivism in itself has these different approaches as well, which is very interesting to study, because we find in activism, in its first formulations, or more explicit formulations, in the works of Maturana and Varela. And these were two biologists from South America. And they start the first formulations upon the notions of building this from within the areas of systems biology, and the notions of autopoiesis and self-organization. So in ways that were very much coming from a systems approach to biology, and that have very little to do with computationalism and computational theory of mind, and way more to do with, for example, dynamical systems theory or complex systems theory. So then we find those grounds where we understand, or try to understand, or have a theory from cells to cognition, through the notion of autopoiesis and self-organization, where there is a quite clear attempt and endeavor to place cells within the body, organs within the body, and the body within the environment, and explain that multi-scale nested level of living systems. So the notion of autopoiesis and coupling is going to serve that very nicely to do so. And then more recent approaches have been the branches that have been extended from the early days of inactivism towards, or from within, or the links made with Buddhist philosophy of mind, which is quite interesting as well, with the work of Evan Thompson, for example, which is extraordinary. And then this other work placing more emphasis on the notion of linguistic bodies, which is quite interesting as well, and how living beings navigate the environment through the sense-making theory approach. And this is works like Ezequiel de Paolo or Ana de Jager, and many other researchers. And another branch that we find in inactivism is what is called radical inactivism by Daniel Hutto and Eric Min. And radical why? Well, because like we were distributing the E's in a range, and we had E's that were closer to computational theory of mind. And as we move further away, we were distributing them by asking the question of how radical are you, in the sense of how much do you reject mental representation as being in a fundamental role to understand and explain cognition, right? So then we are moving away, and then we finally find radical inactivism because of its questioning of mental representation as playing this fundamental role to understand cognition, but also, whatever it is, it's not of the same kind of the mental representation that is explained within computational theory of mind. So this is an attempt, and I am incredibly sorry that I'm not going to be able to do justice. It's an attempt to at least try to have a map that we can build and construct to look at the different E's.
Right. Yeah, that's very helpful. Thank you. And so you mentioned this is all in contrast to the traditional cognitive science approach of, well, mid-20th century. You have this kind of computers, the newest technology that people are using as an analogy to understand the mind, and then computers work by manipulating symbols that stand in for other things, so they represent other things. So you have this idea of representation that you mentioned, and so you have this idea of a brain as an information processing computer, basically separate from the external world, locked away in your skull, receiving information from senses, performing calculations on representations on symbols, and then performing actions, and then the critique of that, because there are multiple problems with that, leading into this more connected view of us being embedded in the world, embodied in the world, enacting our own, even enacting the kind of the meaning that we perceive through our interactions with the world. And so in getting, we need some tools to formalize our theories. And so with computers analogy, there's a whole rich, range of computational models you can use. And then you mentioned that with this approach, you move more into dynamical systems theory and complexity. So I wonder if you could say a bit about that approach.
Yeah, absolutely. So, yes, the view being the computational theory of mind, being that there are this information that you can conceive of or understand or make sense of neural dynamics or cognitive life by reducing it, excuse me, by reducing it to the notion of an analogy with computers. So whatever it is that we understand as a computer with an input and an output and an internal computational process, that is going to suffice for us to understand mental life. And then we have several different theories that are going to be placed to try to precisely explain mental life and mental living in the forms of this computationalist analogy that has been around for a while and has different approaches. So from the point of view of e-cognitive science, there are theoretical limitations with that approach that are laid out and explained within the different theories. So this is the theoretical space, right? And then it could be thought that, that might be a strong theory, but in itself, we do not have the means to understand mental life in other ways other than comparing it to a computer. So sometimes when e-cognitive science pushes back on the analogy, on the mind-machine analogy, one can come back and say and respond that, well, that may well be so in the theoretical space, but comparing a mind or a mental life to a computer is useful, right? So there's been several responses in this form where it is useful, therefore one should continue to, use this kind of analogy in our neuroscience labs or in our cognitive psychology experimental settings. Right. So many researchers and cognitive scientists within the cognitive science theoretical space have responded to this and say that it is not useful. It's actually misleading, and it will assume that we are explaining something that we are actually not. So that's one part of it. But then there's also the more experimental modeling space, where there are tools such as dynamical and complex systems theory, that the tools are scientific and mathematical tools in themselves. They reject the ways in which it would be useful or it would be necessary to think about or to explain or to understand mental life in the form of it being analogous to a machine, right? So these are completely different scientific approaches, scientific modeling approaches. It is important to say that even when one is engaged with either or scientific approach, right? There's also a philosophical standpoint that one is looking at and from. So regardless of the computational / mathematical theory that one is engaging with, depending on the scientific case at hand, there's a fundamental question, philosophical question that every scientist or computational modeler explicitly or implicitly needs to, have an answer to, which is whether they look at these tools, at these computational tools as being ontological predictors or being epistemic tools, sort of like these epistemic goggles that you would put on in order to better view the world, right? So this is a philosophy of science kind of question where what you're asking is, what kind of understanding do I have about the tools that I'm developing and engaging with as a scientist or as a modeler, right? So it doesn't really matter whether you use Bayesian inference, whether you use complexity science, right? What is the most important thing is what is our positionality as a scientist in regards to the tools that we are using, because it is very much possible that I use something like Bayesian inference and predictive coding, and many scientists do, to study the brain. And that has been an incredibly useful tool to make sense of neural dynamics, right? So what it allows us to study neural dynamics by collecting the data that comes from neural dynamics, right? And then start to make some sense about this extraordinarily complex amount of data that we collect. And it is incredibly useful to understand causal relations laid out in a topology of via certain paths lighting up or connecting with other paths given a certain kind of like input. And this is all fine and good. The question there is whether you will look at this particular model that we have developed to understand the collected data from neural dynamics, whether you look at as an ontological prescriber. Right, so the ontological prescriber would be like, right, so then if I do find causal relations and patterns that within my model that uses predictive coding that matches the activity of the brain, then it should be the case that the brain's dynamics can and are analogous, almost isomorphic to the components and aspects of my model. So this is the map territory fallacy, right? So this is the view that just because the map is useful because there is a territory. If they were isomorphic, then the map would not be useful anymore because it would be the territory, right? So this is where you link these things within philosophy of science, right? It's the way, the standpoint and the perspective from which you are using your tools. If it's as an ontological prescriber, then what you're doing is you are confusing the map with the territory, and you're saying that because my map works, my map therefore is the territory. It's an ontology prescriber, right? Or you can still use these tools, but instead you do not go into the map territory fallacy, and you say these are incredibly valuable tools that we as a community of scientists have come to be able to develop as tools that allow us to see patterns in what before was just, shall I say, stuff. We couldn't really make sense of what was going on. It was just these data that we can't understand. But by virtue of putting on these goggles, these tools, and engaging with these tools in the ways that we did, then we were able to now generate all of these understanding. Therefore, these tools are epistemically valuable. So this is a question that it is regardless of the tools. The tools do not give you as a commodity ontology. This depends on the stance of the scientist. What we find in computational theory of mind is the map territory fallacy. It's the theory where one would think that the computational apparatus, the computational machinery that we use of whatever computational kind or computational language, right, is going to be somewhat kind of like an ontology prescriber. It started with Turing machines being modularity, being very useful for the whole development of modularity of the mind, right? So there's always this kind of like, there's been in the history of analytic philosophy of mind, there's been this kind of like, let's use the best technology of our time and establish this analogy and make it an ontology, right? So that's a stance in itself that is independent of the tools themselves and the computational capacities that we have around us and we build as scientists. So then this is all to say that you can engage within these tools that serve or are closer to inspiring computational theory of mind in the theoretical space of thinking mental living without thinking about them as them being ontological prescribers. That's possible. And then within the dynamical and complex systems theory, it is interesting because most people engaging in that space or from that tool point of view, they would reject from the get-go the mind-machine metaphor. So that positions them in a completely different theoretical space as they think about how to move forward these tools and how to use these tools, right? So what we have is, if we go for the computationalism or from computationalist theory of mind premises, then and you think about, you know, mental life reducing to a kind of like a computational processes in the brain, then you are going to be aiming for certain targets, or you're going to be wanting certain explanations. So it's going to delimit in a way. And once you go to computational to complexity or dynamical systems theory, you're gonna have other ways or another a completely different angle, right? Because it's gonna become way more complex, obviously, because you're gonna have many different levels, and it's gonna be looking a little bit more closer to what Maturana and Varela were after, that I mentioned earlier, which is this systems level approach, where you understand that the cell is situated in a cell tissue, and that is going to be relevant for the overall understanding of the system, a system that is in itself also situated in the environment. So you look at all of these influences and interactions and dynamics as being couplings, situated, self-organizing systems in themselves that are mutually influencing one another, because they are open systems to the environment. And I can unpack that a little bit more.
Yeah, that'd be great. But so first, I'd like to comment on I completely agree with this, the importance of differentiating the map and the territory, right? Because it's very common for people to make this mistake. Is kind of to think that their models really capture what the system is, rather than being a model that's different from the system. So, you know, if you think the brain is literally a computational device, then you're going to say it becomes an ontological prescriber. You think because it really is a computational device, it's going to show all aspects of that you expect a computational device to show. Whereas if you understand that you're looking at a system and you're overlaying a useful tool, a useful instrument, a kind of intellectual framework that could help to gain some insight, then you're on much firmer ground. I think, you know, I think this sneaks in because people, when your map becomes really useful and really accurate, I think that's when people slip into the feeling that we've really captured exactly what this thing really is, right? So if I said the retina is a camera, most people would say, well, okay, I get that that's an analogy. I know it's not, it doesn't have an SD card or whatever my digital camera has. But if I said the retina is a light sensitive surface, that feels like actually a true kind of objective statement. But actually, even that claim, kind of what is a surface without a human there to kind of differentiate that this bit of tissue is I'm seeing that as different to this bit of tissue, and actually these molecular changes I'm interpreting as light being transformed into electrochemical energy. So I think even at all levels, if you just always understand that your claims about reality are claims, they're not actually reality in itself, I think you're on firmer ground.
Yes, precisely. It is having that capacity to understand that, or from this perspective at least, that we engage in science as scientific practices, right? So this science is a scientific practice where we advance theory. That's what we do in philosophy of mind when we are trying to understand the mind. We develop and advance, hopefully, theory, right? And that's important, that's relevant. And then in science, when we are computational modelers or engage in computational neuroscience, when we advance models of the brain, right? These are practices that are themselves situated in epistemic communities, right? So in different communities of scientists and researchers, and elaborating and advancing a certain theory. So what I want to say is that there's got to be that humility where we understand that we're all doing our best in our own respective fields, and these tools that we participate, that we help advance with bringing in our ideas, right? They can be seen as goggles. Whichever they are, they can be seen as goggles that we then use and engage with in order to make sense of something that is of epistemic and scientific interest, because we want to understand something, because we are curiosity driven to understand certain aspects of the world. So then we engage in certain different practices to bring about certain tools that were not there before, and certain ideas that were not there before, such that we get to understand those that phenomena that we are interested in understanding as we observe the natural world, right? But you're absolutely right. When, of course, one would be extremely happy and exhilarated when our models are right on target, right? That's excellent. That's fascinating. That's brilliant. And many of these computationalist approaches, predictive coding theories, have been very inspired by that kind of like exhilaration, I think. But I think that we need to also take a step back and understand that it's a scientific practice. So it is okay. That's the thought. It is okay. We don't really lose much. It is okay if the tools are just working really, really, really well. It is okay that they are not ontological prescribers. We don't really lose much. And then what many people, researchers and cognitive scientists would potentially and have come and said is that it is not only okay, it would be problematic to conceive of these tools as ontological prescribers, because then eventually we stop talking about a systems level understanding of the mind, and we start reducing the mind to computational inferences and processes, and then we start losing sight of aspects that are really crucial and relevant for the particular individual experience that one individual has. And the thought here is just that I'm going to give a very rudimentary example, okay? Because then this can be unpacked in all sorts of cognitive psychology. But it's very rudimentary, so just bear with me. So if one would think of the mind in computational terms, right? And when we could even start thinking in terms of a metaphor, because it provides a conceptual, useful toolkit for everybody to understand what I'm referring to in a very tremendously abstract domain, which is the mind, right? So if one would be using that toolkit to understand the mind as a computational or as a computer, the mind-machine metaphor, as a computational information processing machine, that if nothing else, right, if nothing else, that in itself will constrain our views about individual livings, individual or individuality that experience the environment in different ways, right? So that in itself is going to tend to lead us to think that we all have the same kind of apparatus, the same kind of processor, right? So the same kind. So then that places way more emphasis on understanding the mechanics of the computational workings, right? And then way less importance into experiential, individual living or aspects of life that are going to be fundamental for understanding why do humans or non-human animals behave in the ways that they do in their situatedness of their living, right? So much more focus is going to be placed on the computational workings of the brain. That's computational theory of mind, is the computational workings of the brain, with some researchers bringing in the body as playing a causal role in these computational processes. But this is kind of like the end of it. Then you don't really leave much curiosity to be pursued, for example, in the domains of social enculturation, right, or social dynamics, or the environment itself, right? Because you're focusing so much on understanding in the computational lens, the ways in which the brain works. So then you're kind of like, that's the domain in which we are going to be focusing. And that may lead certain cognitive psychologists researchers to live outside of their experimental settings, for example, aspects that have more to do with the experiential dynamics that an individual has had throughout the developmental curve that brings them to behave in such and such and such and such and such ways, right? So that's one aspect. And the other aspect is when it comes to mental health, right? It may lead you also to think that, or to formulate as many theories have been formulated in terms of psychiatric conditions to be conditions of, as it has been in the literature, a disruption in a brain module, right? So things that become very computational, and where the human aspect of it and the very living situatedness aspects of life and development of life or of living are not really brought into play of any kind of role, because you have just construed mental living as a computational process. So then you would think that potentially everybody that has got a brain is gonna, given the same circumstances, gonna, behave in the same way, which from the e-cognition perspective, as well as the more scientific dynamic and complex systems theory perspective, is very reductive, and it will not explain behaviors that have everything to do and require the understanding of the situatedness in a developmental curve, or as we call it, within a trajectory. So now I will give you an example so that we can look at the two different theories and how we are going to look at different things and end up with different results or different understandings. So the thought there is that if you would take in the computational theory of mind and think about mental health or general mental health conditions such as depression, anxiety, PTSD, what one would think is that there is a sort of like a group level analysis where you can say things like on average, right? So then there's not really a differentiation or an angle or a focus on trying to understand the developmental aspects that brought someone, an individual, to be right now in this point in time struggling with this specific mental health condition. So this is going to have clinical implications when in treatment, because we are going to potentially apply the same model to all individuals that come to us struggling with depression, right? So there are practical implications of taking those premises of the brain being a processor, because everybody's got one. So then in the end, there are implications in real life, for example, in the case of mental health. When you go to the complexity or dynamical systems theory and you think about mental health, there is a rejection of on average or applying a model to everyone, right? So there, and this is literature that is very well developed. It's not mainstream, but is well developed. And I can leave some references to it. So when you think mental health from a complexity or dynamical systems theory, you are looking at the individual trajectory of an individual. So you're going to want to study the individual itself, and you are not going to be applying on average models to the individual. So what you want to do is to study the patterns of thinking of that individual, where therapy becomes not applying a model that is construed on average, but therapy is applying change. Is such that we bring an individual to change from one state to a different state, right? So then there are, of course, different strategies, different therapeutic strategies that one can use. But the idea is that fundamentally, it's the understanding that this person comes before us having been through a trajectory of events. And this trajectory of events is their experiential life. And this experiential life cannot be understood as computational processes. If I start talking to this patient or client in terms of their depression as computational processes, that is not going to help them or us or anybody, right? So that's one reason why it's misleading and it's not useful. That's just one. I'll just leave it there. But let's just continue. So in practical terms, I'm going to want to be looking at the individual trajectory of the individual themselves in order to understand how they come from their experiential, embodied, or very bodily grounded perspective and experiences, how they arrived at this state. And then psychotherapy is going to take the shape of wanting to change unhealthy patterns of thinking of that individual, not on average, into healthy patterns of thinking. So then what you get from this perspective is a highly personalized and individualized psychotherapy, which you will not get once you think that everybody's equipped with a brain. So one needs to, so this kind of theory, because it understands the tools as tools that we can apply to anything that is an open system, right? So then we understand that these are tools that we can apply to anything that is an open system, and we can use them for certain kinds of objectives and aims that we have. It can be mental health, but it can be also studying a black hole, right? So it is just the understanding that these tools capture the highly self-organizing and high degrees of freedom of an open system, right? And I'll just drop this here, right, and see how that resonates. So we can use these computational modeling tools across the sciences, right? We can use that in astrophysics. We can use these computational modeling tools in social sciences. We can use in neuroscience, or we can use in climate science. We can use computational modeling in all of these sciences. Why would we want to use and develop these computational models? Well, first, because we want to understand the natural world around us. We are driven by curiosity, right? So that's one reason why. And then the second is because we cannot go around and set up an experiment in order to test a kind of phenomenon that we are very interested, for example, in climate science, right? So then our best next thing is to develop these computational models, right? So then the phenomenon that is quite interesting to observe as we see computational models being developed and used and very useful epistemic tools to understand phenomena in the world that we would otherwise not be able to understand. What is quite interesting is that only in cognitive science, or when it comes to the sciences of the mind and the brain, would we claim that the model has same aspects or is isomorphic to the thing that we are trying to study, right? Only within this space we would say, well, within cognitive science, my model is isomorphic, is an ontological prescriber of the thing that I'm studying. I would never say, well, trying to understand the formation of a storm, that the storm behaves in ways that it represents the world around it. That would be ridiculous, right? And it's interesting because the same tools that we use to generate understanding about the phenomenon and ideally predict future states of that phenomenon, only in cognitive science we would think them sometimes as ontological prescribers. So I'm trying to make this differentiation, and just now coming back to complexity and dynamical systems theory to say that that's not a mistake that is made in complexity and dynamical systems theory. We understand that the tools that we are developing using these kind of mathematics that understands open systems as highly complex because they are in continuous change, interacting continuously with their situated environments. We will not abdicate of the understanding that they are complex dynamical systems. They are non-linear systems. They are coupled with the environment. No matter how hard things get for us to model these things, we will not abdicate from these principles within this kind of like scientific approach. And another aspect that will not come within this theory, computational and dynamical systems theory, is taking that step when employing these tools of thinking that the model that we use or develop, the mathematics that we develop, and the complexity and dynamical systems theory are going to be isomorphic to the mind or the brain or anything at all that we study, because these are natural systems in the natural world, and we are using and developing these mathematics and these models because it is our next best thing as an attempt and an endeavor to have a glimpse over one state of a system that is situated and is in continuous change, is situated with the continuously changing environment, and is precisely right now in a present state, which is the confluence of the sum of all of the situations that the system has been at. And for us to understand that present state of the system, we must understand that non-linearity that the system is at. And that's the understanding that we want to do. And hopefully, ideally, not only understanding that present state, but by understanding the present state as a confluence of the past states, then being able to predict next states. And this is what we do with non-living systems. It's for many non-living systems to understand their dynamics is quite hard. Now, when we're talking about living systems, it's harder because the degrees of freedom, the ways in which they can act upon the world, change the world, and change their own lives increases exponentially. So it becomes even much harder to model and predict future states of living systems.
Right. And so there's a recurring theme here of kind of relationality and embeddedness being important, right? That we're in the world and we're relating with it in a way where, I think science has this fantasy of an objective perspective, that it can pull back and get this perfect perspective that as scientists we're not actually kind of enculturated ourselves and in the situation of kind of cultural embodiment that biases us in a kind of inescapable way. And you've done a lot of work on, especially as this relates to kind of AI and AI ethics. And so I wonder if we could turn to AI next.
Absolutely. So I've just given the example of mental health as being like kind of like a very tangible way of seeing the consequences of these kind of like two different approaches, both incredibly rich approaches, computational theory of mind, dynamical complexity systems, right? And I've given mental health as one example where we can see how it can play out and have consequences in the real world for real people right now, right? Another consequence is AI. So my research has been so mostly on cognition, and then more recently transitioning into AI. How has that come to be? Well, because my research has been and is on how cultural aspects of the environment affect and influence cognitive life. So how the environment shapes and is shaped by our mental life. So that's been the focus of my research throughout the years. And then more recently, I've been focusing on one aspect of the environment that has become more prominent more recently, which is artificial intelligence systems that are pervasive, permeating our lives, and how they impact or can impact negatively or positively our mental lives. So by mental lives, what I'm interested is not in mental lives as computational processors. Otherwise, I would not be developing what I'm going to say next. That's one of the disadvantages, I think, from my perspective, from my philosophical perspective. It is one of the disadvantages of taking computational theory of mind route. It's because it would not allow me to now say what I'm going to say next, which is what I'm interested in understanding. I'm interested in understanding how AI systems are going to affect the experiences of people, are going to affect mental life in terms of cognitive development, in terms of our cognitive flourishing, in terms of our belongings in our communities, in terms of our cultural practices and narratives, in terms of the ways in which we define ourselves, right? And this is because I come from an cognition approach. Otherwise, I would not be able to have all this variety of toolkits to talk about these things or to have a curiosity driven towards the experiential side, right? So this comes to me in a very organic way, understanding from other traditions, right? To understanding this situatedness is understanding that different people are positioned differently in social cultural power dynamics. And this means that people in general are differently going to be affected by phenomena that occurs, right? One of them being, that's the one that we are focusing on, AI, right? So that's an understanding of the situatedness of mental life, right? We could talk about this without AI. We could talk about this with the example that we had before, which was on mental health. I'm very interested in understanding how did you arrive into the present state, which is what we refer to as a depressive or a depression condition, right? So let's study what kind of like experiences did you have within a social cultural environment from your own positionality that, you know, launched you, that brought you to develop this kind of state. So that's mental health. AI is not very different because it's another aspect that is in the environment and ever more prominent. So the environment is shaped and shapes our cognitive development, flourishing, and belonging in our communities, right? So the thought there then becomes studying and understanding a feedback loop where you want to understand how AI, this would be the general question, how AI shapes and is shaped by cognition or cognitive practices or human practices. Now, let me unpack that a little bit. So on the one hand, you want to understand how the pervasiveness of certain AI systems is going to impact our social cultural organization in general, and in the many levels of society, such as education, healthcare, mental health. So you want to understand how AI is going to impact, and then you can formulate many different focused experiments to understand those impacts within psychology. You can formulate many different experiments to understand those impacts, right? But you need to come from a place of situatedness. You cannot come from a place of on average. Because if you come from a place of on average, you have not understood that there is a situatedness on social cultural power dynamics where different people coming from different groups of society are going to be influenced differently by the AI systems, right? And we could go on now into ethics of AI and understand how unbalanced the influences are going to be for different groups within a society, or even within the human society and the different East and West societies. So you have to come from a place of situatedness, right? And from a place of cognitive science to have that kind of toolkit that allows you to now focus and grasp on the experiential groundedness of the body to understand why some people are affected differently. So you need that toolkit. And then, so this was the one part of the feedback loop. Our AI shapes differently people situated in cultural practices. And then the other part of the loop is how certain cultural practices and the way societal organization and power dynamics are going to give rise to the emergence of certain specific forms of AI systems. And I will unpack that. This is not something that I came up with. It's something that I took inspiration from Maturana and Varela, where the view there was about scientific problems and how to solve them. And what they say there is that problems to be solved, human problems to be solved, they do not arise as from a parachute and land on us and like, oh, okay, so now let's solve this problem. That's not how scientific practice works. So the human problems, or the problems to be solved, are problems that come within and situated themselves within a specific social cultural practice, right? So the idea is, and then I expand that to AI, the idea there is that we do not have infinite resources or infinite energy or infinite time, right? So then we as scientific communities, or shall I say we as techno-scientific communities, must decide where we are going to allocate our time, energy, and resources in order to develop certain kinds of technologies, right? So what technologies are we as a community, techno-scientific community, are going to determine as the ones that are worth investing our time, energy, and funds, right? So then throughout the years and history of science has shown us that throughout the many years or the longest time in technoscience, the resources would be, allocated to the interests of the main group that was engaged in science, which was the West perspective, and which was a very male dominated. So then you come to have science that has certain kinds of problems that is being solved with certain metaphors and analogies that are very male gazed. And you notice a difference when recently you see much more diversity within science, that the problems are more varied and the approaches also vary. So the thought there is just situating how AI is developed within these techno-scientific practices. So that's what I'm doing, right? I'm situating AI development within those social cultural practices. So when we come up with these AI gadgets or systems, these are not ideas that come out of nowhere trying to solve problems that parachute on us and now we are going to develop this system. No, these come from very human situated concerns that we want to address. The whole goal of AI has been for the longest time to produce a system that looks like us, right? But it's in, of course, a very rudimentary way. So then the other part of the loop comes to how certain specific social cultural arrangements are going to give rise to specific AI solutions rather than other AI solutions, right? And quite interestingly, today, a couple of years ago, mostly 1 year ago, we have arrived to large language models. And large language models, they very clearly illustrate the most profound and genuine goal of AI, which is to develop a system that very much looks like us. So then what we have with LLMs is precisely a system whose entire goal is to look like us. It's not to generate facts, it's not to give us knowledge, it's to seem like it's a human being that is talking to us, right? So in certain ways, one could think about large language models as the Chinese room by John Searle. But at the end of the day, there's much research at the moment on how they are confabulates and how the systems could be seen as hallucinating because they do not provide facts. They're not fact checkers. They do not provide knowledge, and they should not be used as such engine. But we did achieve the main goal, or we are on the way of continuing the main goal of what we wanted to do with AI, was to produce something that really looks like us. So that itself is an achievement of AI. But the idea there is that these are developments, that are technoscientific developments. AI art is a kind of technoscientific development that is profoundly highly situated on our kinds of social cultural settings and power dynamics, where we are going to develop the kinds of solutions that are going to serve that specific kind of community's goals or problems that they would like to overcome.
Right. There's so much more we could speak about, but unfortunately we're out of time. Thank you so much for giving me the time today. Where would you send people to if they want to look into your work more?
Well, just my website really is usually what's the most updated. Just myname.com.
Great. I'll put it in the description, and thank you again.
Thank you.
Thanks for listening. If you're watching on YouTube, please like and subscribe. And if you want to help the podcast reach a wider audience, you can leave a review on Apple Podcasts. Finally, if you want to offer financial support, you can go to patreon.com/Dr. James Cooke.